Okay, so today's session is on Azure Data Lake. So what we would cover today is not only specific to Azure, but it's common for any data lake. If even if you are from a different background, like if you are working with Amazon S3 or if you are still like working on-premise data solutions, you can still use the concepts from this session. Okay, so uh, so the first question that comes to our mind is what is a data lake, right? So as the name suggests that it has to do something with data, right? So the further question is then what is that we want to do with the data? And again, the answer is very simple and it's very obvious, right? We want to uh, primarily do a couple of things with the data, right? One, we want to store the data, and number two is we want to query the data, right? It's as simple as that. So it's very simple as it sounds, but in real life and in today's world, to be more specific, uh, the explosion of data has been to such an extent that it was never predicted, right? So it looks like the existing storage solutions, the hardware, the infrastructure, they are falling short of like when we talk about sheer capacity to store the data, right? So uh, and that is one of the reasons why the technologies like data lake have come into picture so much today. So let me tell you that many big enterprises like Microsoft, Google, and you just name any other big enterprise, they have been using their own data lakes for almost a decade now, right? And specifically the companies who provide you search solutions like Yahoo, like Bing, like Google, right? So they have been maintaining their own data lake, and it was on premise, and it was not affordable for mid-scale or even consumer users because maintaining such a data lake, the hardware, the network, the infrastructure that it needed, it was simply people could not afford. But now with the drastic reduction in storage costs, even small scale businesses, startup businesses, and even consumers to some extent for their learning, maybe even, so they can use these infrastructures, right? Because they have become so cheap. So what people have started is in like just to get rid of the pain of maintaining an on-premise data lake, many enterprises have started providing this as a service, right? So like we all agree, right, that maybe 10 years down the line or 5 years down the line, most of the solutions that we have are going to move to the cloud. Most of the data are going to move to the cloud. I agree that yes, not all data, some data are very sensitive, so let's not talk about that. But the point is most of the things will be on cloud. So uh, as a service, when you get a certain thing as a service, you are freed of any headache of maintaining, installing, configuring, administering the entire infrastructure and stuff like that. So with everything, we already have Hadoop as a service, we already have machine learning as a service. So we are also going to have data lake as a service. So internally, when we talk about Microsoft, we have been using a framework called Cosmos. Okay, so it's based on an engine called Scope, and that's basically our internal data lake and the big data framework that we have, that Microsoft has been using for a long time now in solutions like Bing, right? So now what, with everything going as a service, with the trend going towards the cloud, what Microsoft did is we have partially exposed some features of Cosmos to the public cloud, so that any user with a cloud subscription, with an Azure subscription, can use those services. And these are like very well tested, and very well, like we are very familiar with the entire stuff because it's something that was internal. Some parts of it are made to public. So what are those parts? We are going to see. So the main the concept of data lake is nothing but, yes, it is a data storage and data query or data retrieval system basically. But the main idea is enterprises or companies, they would have their entire data for the organization in the data lake. So currently what happens is, some of the cloud-based applications, they spit out their logs and their telemetry data to the cloud. Your on-premise systems generate the logs in your on-premise system. So at the end of the day, when you want to do a big data processing, like aggregating all the logs and coming to a conclusion, seeing the intelligence out of the data, it will be the first step is to aggregate the data from different layers or from different places, right? So that's a big tedious task that we have today. So the idea behind data lake is that it will release you of all that stuff, because every data or any data emitted or spitted out by the company. When I say the company, that means your digital data from your applications and stuff like that, right? The logs, the server logs, the network logs, maybe the social sentiment stuff, data, stuff like that. So you have everything in your data lake. So you don't have to run to different places when a certain application requires a specific data, and you can reuse the data for other purposes. For example, even if you are not analyzing the data right away, the data that is there in your data lake store, you can use the data to train a machine learning model, which is a part of a completely different solution, right? So it's the reuse of the data for other stuffs. Currently, what companies do is they have to buy data from the data market, the data to train their models. So that part will be removed as well. So again, the basic idea behind data lake is as simple as a single repository of any and every data from your organization at one place. Okay, we'll go into the internals as we move. So again, the session objectives are you will be able to understand what the data lake is and how Microsoft offers things as simple as I mean, we'll see in a few minutes that again, the basic thing that I loved about Microsoft going right back 10 years back when I started my career was Microsoft made things really easy, right? So when I started with C++, when I started with Java, I just absolutely fell in love with Visual Basic, just because the intuitiveness, the GUI, the user friendliness, and the ease of the language to build something really good with very simple steps, right? So Microsoft is always good at that, at making things simple. So we are going to see how simple it is to get started with big data analytics in just a matter of few minutes using the data lake technologies that we have in Azure. Again, just remember that these are all as a service. So there is merely anything that the end user needs to do apart from providing the correct inputs. I mean, absolutely, you have to know your data and you have to know your requirement really well, right? So that part you focus on, you come to us with that, and then you'll see how easy it is to run your big data jobs. I have faced many developers coming to me saying that, hey, I'm a .NET developer, hey, I'm a Java developer, can I go to big data? Now the answer is really yes. The answer was always yes, but now it is very simple. The learning curve, the training time for a .NET developer to get started running, and executing big data jobs, Hadoop jobs, MapReduce jobs is really easy. We're going to see that. So that's what we are going to look at in today's session. Okay. Now, again, as I said, a data lake is basically primarily a couple of things, right? One is your data storage, and the other is your data analysis, like retrieving the data, querying the data. Now, we'll first take a couple of slides about the store, or the data lake storage. So again, when we talk about Azure Data Lake or ADL, it's actually it comprises of two parts. One is your store, which we call the Azure Data Lake Store or ADLS, and the other is your Data Lake Analytics. We call it ADLA. All right, so let's first take a look at the store. The store is really simple. Again, one more prerequisite that this session had, which I should have probably mentioned earlier, but the prerequisite is you should have a good understanding about HDFS and a good understanding about any distributed, big data processing framework like Hadoop, right? If you don't know these, probably a couple of things will go above your head. So I suggest you go back, take a look at these basics, and then probably you can see the session again. All right, so. Just like HDFS, the data lake store is also, the files are like split by partitions, which we call extents. The size that you see, 250 MB, it was there when data lake was in preview. This slide is a bit old. So currently the extent size is 2 GB, right? So we will see what is the implication of this extent later. Okay, so it's like 2 GB. Again, just like with any other Azure services, any data storage services, we guarantee that we will not lose data. So any data is replicated. So in this case, the extents are individually replicated 3 times, okay, in different data centers. And one very key thing about this store is it is optimized for parallel read and write. Okay. So when we talk about storage, data storage in Azure, the first thing that comes to our mind is Azure Blob Storage, right? But this is not blob storage. This is a bit different, right? Blob storage is more of a general purpose cheap storage. This is also cheap, but this is not general purpose. This is optimized for multiple concurrent parallel read and writes. Okay, it's optimized for that so that it can serve its queries faster, and it's optimized for parallelism, right? So that means different threads can read or write into the different extents of our store. Okay, uh, that's one key thing about store. The other key thing about the store is it has no limit. And yes, you heard it right. There is no limit. So anything in Azure, it has a limit, right? For example, document DB has 10 gigs for tier one. Even blob storage has some like max size. We have faced customers every now and then coming to us, hitting some of these storage limits. So in this case, we have released it. Like there is no upper limit for the volume of data that you can store. You can just add on. As I said, the idea is that any data will come into the lake, right? So you can store indefinite amount of data at the infinite volume, no limit on max size, and there is no need for a specific schema also, right? There is no block blob or page blob, any stuff like that, right? So you can store data at its raw and native format. Again, the idea is the company won't even bother about what format the data is, right? Before putting into the store. The idea is that every application will have an automation part where it will automatically spit all the logs or all its telemetry data to the data lake. So it doesn't need to worry about format. You can just store any data at its raw native format, and there is no limit on size. There is no limit on individual file size either. So a single file can be of any size, right? It can be 2 exabytes. So there is no limit. So that is a few key things about the data lake store. Again, it's modeled on top of HDFS. That's another important thing. That means people who are familiar with HDFS as a user, they will not see any difference. It's completely transparent to the user. User can run and execute commands as they execute commands in HDFS, right? So they used to prefix HDFS : before the commands. Here you have to prefix this with ADL : right? It's as simple as that. So it's just another file system added to the trunk, right? So that's basically about data lake store, which doesn't excite me that much as the other guy, the data lake analytics. That's simply very exciting stuff. So let's take a look at the data lake analytics basics. Again, the need for analytics is very simple. You now have the data in your data lake store. You now need to query it. So the query should also be parallel, multi-threaded, right? Because the data lake store is optimized for that. So if you don't leverage a parallel read and write from the application, then there is no use. So data lake is built exactly like that. Okay. Again, all of this is part of the internal tool. Just a reminder, called Cosmos. We have had them for years. We have exposed selected parts of it as a part of data lake store and data lake analytics, right? So it's really exciting. So taking a step back, what Microsoft offers today on Azure as a big data platform. So one is, yes, your IaaS, right? Infrastructure as a service, Hadoop. You can always acquire VMs, manually install, configure, maintain, patch the individual VMs and the OSs and the Hadoop distribution. You can install any distro. You can install Hortonworks, you can install Cloudera, Mapr, anything, just anything for that matter. So, but the big pain is that it's as good as, maintaining the on-premise big cluster. It's just that the VMs are in the cloud. So it's very tedious and painful, right? So then we had HD Insight, where we made that installation management stuff relatively simpler, right? People can just, with a matter of few clicks, they can have scripts to deploy the clusters with their desired number of nodes, but still there is a significant amount of manual work or manual interaction with the cluster that is needed, right? To submit jobs, maintain the cluster health, install any specific software, then in NVIDIA and stuff like that. So there is still a significant bit of manual interaction. And then we came up with data lake analytics. So personally, I see this as a next generation of data services, right? So what data lake analytics tells you is rest your worries about the infra, right? The hardware, the CPU, the RAMs, forget about it. Focus on your job, on your query. Again, as I reiterate, I emphasize on the fact that you have to have a very good understanding of the data that you have and the data that you want to query, right? So please focus on that. Build your query. Don't worry about the clusters or the resources that will run the query. You build the query, you submit it to data lake analytics, and then we will create the clusters needed. We will allocate the resources, the CPUs, the RAMs. We'll take care of everything. We'll run the query and we'll give you the results back. So you can think this as a job as a service, or big data as a service, or query as a service, whatever you want to call it, right? So it's as simple as that. So this is a big step, and I'm not aware of any other competitor like Amazon or Google having any such service like this. So that excites me a lot. And yes, of course, It does support data lake store as its storage, and it can support blob storage as well. So again, the beauty with data lake store is, as I said, that it's just like HDFS. So any HDFS compliant tool like Hadoop, Spark, HBase, Storm, Thais, you name it, and they will all support data lake store. Just again, as I said, the prefix will change from HDFS to ADL colon. So just it's just another file system, file scheme URI, right? So it's as simple as that. Again, yes, we know Microsoft loves open source. We have been telling this in every conference for the last couple of years. What the fact I want to emphasize here is the relationship with Microsoft and open source is not only get, it's also put. So we also contribute heavily back to the open source, right? So Azure Blob Storage or Windows Azure Blob Storage is now a file system committed in the main trunk of Hadoop. So it's just a new file system that you have added. So that will give people a lot of flexibility. So I'm hoping that many of us are aware of Yarn, the next generation of MapReduce. So when Yarn initially came up, it has just supported barely a few hundreds of concurrent nodes, okay, that it could support. Microsoft contributed heavily on Yarn, and we came up with something called Yarn++, which now supports like a few thousands of concurrent nodes. So the idea behind all this is simply is that to let you know that Microsoft is contributing back heavily, right? And it's like we have thousands of developers who are contributing to the open source stuff. So just to give you an idea on how the data lake analytics works, it's very simple to Yarn, and it's, as I said, that even the store is very simple to HDFS. So it's basically the same thing, but the underlying architecture, the implementation is totally different. Okay, so again, those who do not have much idea on Hadoop, it's a very high level view, right? At the bottom, we have a reliable, scalable file system called HDFS, and we can have data lake store as well. And then we have Yarn, our resource manager stuff that manages the allocation of resources that is needed by your jobs or queries. And then at the top, what is that? It is nothing but you, right? It's a client program that submit the job. So that's basically the framework of Hadoop, and that's how the data lake analytics work as well. Okay. A quick look at where data lake analytics fit in. Now, you see something in the right that says USQL. Yes, don't get scared. Yes, this is yet another language by Microsoft, but it's very simple. As the name suggests, it's a combination of SQL. You can write select star from where group by, right? Very familiar SQL statements, and you can leverage the full power of .NET as well. So you can use .NET constructs, you can use custom assemblies, and you can fully leverage the .NET platform, in other words, right? So the language to author the Azure data analytics jobs is USQL. Okay, so we will see it in a while. It has a very great integration with Visual Studio tooling, right? So that the part I love the most. Again, personally, I love Visual Studio, and any Visual Studio developer will find the integration really great with data lake analytics, really interesting. So we will see it in a while. So a quick look at where ADLA sits in here, right? So we going back, we started traditionally with MapReduce, which was predominantly batch. Like you submit the job, you get the results tomorrow. Then we came up with Thais that became really popular, right? It improved the Hive query performances by almost 100 times based on direct acyclic graphs. So very common framework, but now the requirements, as and when more and more type of data originated, the requirements changed, right? Apart from batch, we also need interactive, right? When we say interactive, that means something like a notebook kind of an experience where a user sits on a terminal, gives some commands, and gets the data back instantly, right? So it's interactive. We need streaming, right? A lot of programs stream in data continuously, sensors, IoT, right? So we need to handle that streaming data as well. And we need to have machine learning. So more and more we get the data, we become rich in data. Our machine learning also improves because the models are getting more data to get trained on, right? So machine learning is again something huge. So that's where Spark came into the picture. I'm sure many of you have heard about, many of you have requested me personally to do a session on Spark. Probably I'll do that sometimes, but again, Spark is something that you must have heard very much everywhere, like in a last couple of years or so. That just because Spark has the framework to support all of these data processing frameworks, right? You don't have to install multiple tools for your needs. So Spark is like, it can host all this batch interactive streaming ML within itself. They have its own, it has its own library. So that's why Spark is so popular. And if you see ADLA, it's just like Spark. It sits beside Spark with the same set of features. As of now, ADLA came to general availability. It was in preview. It came to GA in November, if I remember correctly, or in October, like very recently. So as of now, we only offer batch. Okay, you submit the job and you typically wait for some time to get the results back. And work is in progress where ADLA will also support interactive streaming and ML. I'm just looking forward, right? So that will be very exciting. And at the bottom, again, the layer is Data Lake Store. As I said, if you remember, it's like HDFS. So if you ask me, is Data Lake Store HDFS? My answer is no. It's not even close to HDFS in terms of the internal implementation and architecture, right? So if there is enough interest, we can go on a session which takes you that deep as well. But I think as of now, this will be good enough. So again, Data Lake Store. The fact that it makes it just like HDFS because is that it exposes a protocol called Web HDFS. So this is a very popular protocol. So this actually exposes the interfaces for your HDFS for the REST requests, right? So any HDFS compliant tool, as I said, like all the above that you see, they will all work seamlessly with Data Lake Store also, right? Now the key concepts of Data Lake Store. So as I said, the analytics job need to be optimized for parallel read and write also, because to take the advantage of the fact that the store is optimized for, right? So that's one very key concept of a data lake analytics job, is to determine the parallelism of your job. So when I say parallelism in simple terms, you need to determine that how many pieces of chunks you want to break your job to and like to run them parallelly, as simple as that. So you need to decide, as we can understand that the more parallel a job is, the faster it would be, right? It's common sense. Multiple threads will do multiple things, so it will finish faster. So you will get obviously performance benefits, but you have to incur costs also. The beauty of data lake analytics is that it allows you to choose the level of parallelism or the degree of parallelism. So in other terms, it gives you predictable performance. That's a very key term. When I say predictable performance, that means if you run a job 10 times, you will get the report 10 times back in the and the duration will be exactly the same, or probably it could be one or couple of seconds here and there, but it's kind of a predictable performance that you will get. And the beauty is you get to select the level of parallelism. That's the key thing, right? If you want, you can make it highly parallel, or if you want, you can make it sequential, depending on your needs. And it's as simple, as increasing the bar in the slider. We will see that, right? So the key concepts, you need to know about AdLow. Okay, it's a kind of cryptic term. You can call it AU also. It's basically Azure Data Lake Analytics Unit. So this unit actually defines the degree of parallelism. If you say 1, your entire job will be sequential. If you say 10, your job will be broken down into 10 chunks and they will be executed parallelly, right? Again, this is actually nothing but a container. So if you understand, as I said, prerequisite yarn is necessary. If you understand container, it's nothing but a unit of resource, right? So when you submit a piece of work to your cluster, it will allocate certain resource to perform, that will execute your job. So that resource is called a container, and it's typically at a higher level a combination of your CPU cores and the memory. So here in data lake analytics, it's one AdLow is almost a container of 2 CPU cores and 6 GB of memory. Okay, so if you say 10 AdLows, there will be 10 parallel threads running to complete your job. Okay, now this 2 cores and 6 GB of RAM is not written in stone. Basically, work is again in progress to make this more dynamic, right? Depending on your job, if it is CPU intensive or if it is memory intensive, you can get a container with more cores or more RAM for that matter, right? So work is in progress to make this part dynamic as well. Now this is something what you see in the portal. Okay, so you see there's something called max parallelism. So this is for your account. So an account can have multiple jobs. So the basic flow is like you create an Azure Data Lake Analytics account. The only prerequisite is that account has to be associated with a Data Lake store, which makes sense. And this account will have a max parallelism, right? That is 60. I think it is increased. As you see, the screenshots are from preview. I think it has increased. But anyway, 60 means that all of your jobs that you have under this account, only 60 threads, or you can have a limit of 60 AdLows, okay, basically. So this is something job submission. So again, this is just a simple workflow of the Cosmos. I'm sorry, yeah, it's just Cosmos you can say also, but it's just like the workflow of job workflow of the data lake analytics job when you submit. So typically it gets compiled, validates itself for if the input files exist and stuff like that. Validates the assemblies used in the USQL catalog, and then it goes to the queue. Based on the available resources, the job manager will set it to execution. It will get the resources from Yarn, and finally it will go to the USQL runtime where the USQL code is actually run. Okay, a term that you see that we have not encountered before is called a vertex or vertex execution. Now, what is a vertex? That's a very important piece that we need to understand. Okay, so whenever we submit a job, the job is broken into several small pieces. Okay, these pieces, individual piece of work is called a vertex. Okay, don't confuse it with the adlaw. It's independent of the adlaw. Okay, whenever we submit a job by some kind of magic, uh, the Azure Data Lake Analytics service figures out that okay, I'll break this job into this number of vertexes or pieces of work, and then depending upon the number of adlaws, each vertexes will execute it, right? So for example, if you say select star from a file, okay, that file is residing in your data lake store, and for example 4 GB of size. Now what the data lake analytics will do whenever you submit the job with the select star from query, what it will do is it will split the work. So basically the work is to pull the entire file, right? The entire data from the file, 4 GB. That's what select star does, gets the entire records. So that 4 GB of data, the analytics unit, what the analytics service will do is it will hypothetically split it into 4 chunks of 1 GB, right? And suppose you have chosen the degree of parallelism or adlaw to 2. So for example, so you have set it to 4, right? So that means is there are 4 units that can run your job, and it is broken into 4 pieces of work. So what will happen is each adlaw will process 1 GB each, and the results are aggregated finally, right? So it's multiple processing, it will be faster. But if you have 2 adlaws, what it will do is it will process the first 1 GB chunk, because you have only 2 adlaws, while the other vertexes will be queued, right? So you understand the concept of vertexes, right? It's a piece of work. Now the question is, how is the number of vertex calculated? So again, if you go back to the store basics, it breaks itself into extents. If you remember, that's again very similar to HDFS, right? The input file split. So based on that input file split, or based on that extent size, the number of vertexes are calculated. For example, as I said, it is 2 GB in size, right? That means a 4 GB file will be broken down to 2 extents, and that means when you submit a job, the number of vertexes created will be 2, right? Because it's dependent on the extents backend in the store. Now right now this value is hard coded, right? You cannot change, you cannot choose the number of vertexes. It's automatically determined, and it has nothing to do with the adlaws. Now again the thing is, if you have a huge file and you have 100 vertices, and now you have only 10 adlaws, only 10 vertices will be processed, right? And the remaining 90 will be in queue. As and when the adlaws get free, your vertexes are so depending. So again, you need to know your input split, you need to know your data, you need to like handle that, and then you have to see that how many vertexes are created for your job and what are the number of adlaws. So based on that, you have to adjust. You can over allocate where there are, like if there is only a 1 GB file, there will be one vertex, only one vertex, right? So if you have 10 adlaws, that doesn't make sense, because only one vertex will be processed by one adlaw. The rest 9 adlaws are idle, and you pay for that. Remember, you pay for only the adlaws. Okay, so you can over allocate or you can under allocate. As I said, if you under allocate, the vertexes will be in queue. So again, that will make your job slower. So you have to know the number of vertexes and then adjust the adlaws that we will require. Okay. Now this is a typical screen from a Visual Studio. It's a Visual Studio, right? And we are going to see this in a short while as well. So this is actually a screen of a typically when a ADLA job ran, or we can also call it a USQL job. Okay, so at the left you can see some of the stages, right? We'll see what those stages mean, and then some stats, right? The submit time, the total duration, and stuff like that. How long it did it take in compilation, and there's something like parallelism. So that means I have dedicated 5 add laws, okay, to this job. So only 5 vertices or 5 vertexes will be run in parallel at the same time, right? And this job total, it took 3.8 minutes. That's the total duration, right? So on the right hand side, you see a lot of green blocks. We have these blocks enlarged in the following slides. So if it is not visible, I'm sorry, but I couldn't fit it with a bigger size. So if you see at the top, there are some the ones with no color. They are all input files, .tsvs, tab separated values, right? So and then the green blobs, they say something like extract, they say aggregate. So these are the actually the pieces of work. So again, this is not one vertex but a collection of vertices. So each of these green blocks, they are called super vertices, super vertex, okay, SV, or we can also call it a stage. So again, when a job comes internally, ADLA breaks it into different stages, okay. Again, each stage is a collection of one or more vertices, okay, and they execute each stage. So all green means all well. If you see at the screen, there is some legends which say green succeeded, amber failed, blue running. So eventually when you run a job, when you submit a job, you'll see this thing moving. So guys with familiar with SQL Server integration services, SSIS, yeah, it's something similar to that, right? And the beauty is it's all from Visual Studio, so you don't have to go anywhere else. And there's one more thing in the left side. If you see, it says the vertices. So depending upon the input split size for whatever the input files we are processing, the job broke itself down to 19 vertices, okay. And then each stage, if you see, there's a one vertex, so then it makes sense, right? It says the first operations are extract, so it means like it's pulling data from some source, right? Then there is a super vertex process, that means it's doing some processing on the data. Then a couple of guys, they say aggregate, combine, right? So these are all operations that are happening, and finally it is written to some output at the very bottom, right? There's again another one with no color. So again, some results are aggregated and sent. So that's how a job looks when you run it. That's the job graph from. So this is the physical execution plan of the job, okay. So I hope I'm clear with the vertices and the add laws, okay. The parallelism is 5. That means only 5 vertices. When we ran the job, only 5 vertices ran in parallel. Okay, the rest 14 were queued. Once those 5 completed, the other guys that were queued, they came into the running queue, right? So it typically says if I increase my add laws or parallelism to 19, this job will execute faster. Okay, so it's as simple as that user having the control of what performance you need, right? So that's simply amazing. And we will see how to get that control, right? How can the user choose? It's very simple from Visual Studio itself. So yeah, the job statuses that you see, we'll just see what is the backend stages that is happening. So you see preparing, queued, running, finalizing. So what happens when it is in preparing? That means the job script is submitted and it's getting compiled. And when it says queued, that means the job enters the queue. Again, all jobs have to enter the queue. Why? Because whenever you submit a job, the first thing that Data Lake Analytics Service will check is, are there enough free add laws that can run the vertices? If it is free, it will allocate and the jobs will come to running state. So every job will go to queue state for that validation to happen. And as you say, queued, scheduling, starting. These are all in the queued phase. Okay, that's happening behind the scenes. And then running. So it's now executing the code on one or more add laws, right? Or finalizing the output, or it's like writing to the output, right? So that's the running state where each vertices are getting worked by each add law, right? And then it's at the end, the job is concluded when it ends. So it can succeed, it can fail, or you can also cancel the job. So that's what happens in the backend. Okay. Now this is a enlarged picture of a super vertex or a stage, right? So again, if you see some stats on it, so you can get to see how many vertices are there that processed in the stage, what is the average time for each vertex, and what is the number of, as you can see that there are 252 pieces of work that came in this stage, right? And each vertex executed for 2.54 minutes, or like nearly 3 minutes, and we didn't process too many data at all, right? It's like just 4 billion. So that's the total volume of data read and written that you see at the bottom. So one thing to remember here is all the add laws will perform the same work for all the vertices in a certain stage or in a certain super vertex. Okay, that's something you should remember. Now, things that we are interested in, the job cost. Yes, it's 5 cents plus minutes into your ad lows. So it's a calculation that you can see later also in this the website. I think it has changed a bit also because this slide is during preview, so you can check it out. But basically, it's always calculated on the units of the ad low. Okay, so you have to be careful on the cost. If you don't need a very high performance, you can choose with a lesser number of ad lows. Okay, we will take a look at the Q&A later. First, I want to show you uh, the Visual Studio guy. Okay, so let me just go to my another machine. And here is Visual Studio. Okay, forget about it. I don't want to show you all these things first, so I'll close everything. So the first thing that you would see is the Server Explorer. It's our good old Server Explorer. It now gives you an option to connect to your Azure subscription. I have connected with mine, and you can see the Azure services that I have deployed. One of the branches, one of the nodes, it says data analytics, right? When I expand this, I'll be able to see all the data analytics accounts that I have under this subscription. Okay, so there are multiple. I'll just choose one of them. Okay, data insights. So it says jobs. Okay, so I'll just open the job browser and we'll see the jobs that are under this account. Okay, we'll see a number of jobs. So it's one of our production clusters actually. So at the back end, they all are like, again, clustered execution, distributed execution. So these are the list of jobs at the left side. Let me just close this guy and this guy too. I hope something is visible. So this is basically the first job that I have selected. So it has been run, and you can see there are some stuffs like total duration 4.1 minutes, right? The submit time, the compilation time 32 seconds. The bytes read, like I think it's some kind of like 3.5 gigs of data and bytes written. One interesting thing, the total duration and the total compute time, right? The total duration says 4.4 minutes. The total compute time says nearly 60 minutes. So that's a clear indication that something must have happened parallelly, right? So the total compute time that is spent, the billable time that is spent is almost 1 hour, but the entire job took only 4 minutes. That means these are the vertices were ran in parallel. Okay, if you see the total vertices, so it's a very big file. So based on that input file size, split size, or the extent size, this job has broken itself into 679 vertices, and the parallelism was set to 50. That means 50 ad lows ran 50 vertices at a time, and that's how the job took the entire 4 minutes, right? And this is, I have just magnified this job graph. Okay, this is the job graph where it reads from the input files. It does some extracts. As you can see, so this extract had 19 vertices, and each vertex took 1 minute of time, and it processed a lot of data, right? 16 GB data. So with approximately 1 minute per vertex, so 19 vertices would have taken roughly 20-25 minutes. So that's a huge data processed in a very short time, right? So that's how the different operations went through in this ADL job. Okay, and that's how it completed at the end. It wrote to some output file. Okay, when you just hover over this, you will get the detailed highlights, like what is and what are the things that it processed, right? So you get the details. Another good thing is, so for example, suppose something went wrong. Okay, now the performance was very slow. Now the total time was like, so you run this job daily, you see it 4 minutes, the total compute time is 60 minutes. Now suddenly one day you see the total duration went to 10 minutes, while the total compute time is still 60 minutes. So something happened slower. How do you debug? How do you identify? You can do something called a job playback at the very bottom. So if you do a job playback, okay, it will ask you to load the profile. So this is basically, it will download the data from your Azure Data Lake Store accounts. It will download the data that is required for simulate the run, right? So you can either say okay to that, or you can separately load the profile from here using this button, right? So it says loading the profile. Now the profile is loaded. Now you can do the playback. So see, it will show you. So again, blue means it's running. So this guy is running, it's taking some time, I can see, while the other guy is finished really quick, right? So that's how we can see how the job is performing. So see, these vertices have started, right? They are executing. Okay, for some reason I can't go up. So this is how it is progressing. So in case there is an issue, you can just see which stage took a very long time, and then you can debug that specific stage, right? So that's great from debuggability standpoint, right? You can get some diagnostics if there are some issues. So if there is some issues, it will take you, like you can go to resource user and see what was the problem. So this is the AU resource, right? So this says allocation, like 50 ad allows were allocated, right? So you see this blue line is the allocation, that is 50 ad allows, and this is the usage. So we can say that it was kind of under allocated till here, but then it rose, it picked up, and it actually used all the ad allows. So at some time all the 50 ad allows like worked in parallel, and they processed 50 different vertices. Okay, so that's how we can see more details from this screen. You can see the history, you can see some metadata operations that happened, and what you can do is you can just say build here. It says building at the very bottom left. So let's give it a few seconds to build. This is a big job, right? So what the basic intention is to show you the uSQL script for this, right? So it's a live job, so we can see, and I'll also show you how you submit the job, right? So the build completed. Yeah. So the build completed. The 24 seconds it took. This is the job graph, and now we can have a link of the script. So I'll just say script, and this is the uSQL job for us, right? If you see, it's very simple, right? So anyone can actually make out what this guy does. So it's clearly sees that I'm extracting some data. I'm having a variable called search log, and I'm extracting some data, some columns from this file, right? And there's a using statement that suggests that it's like C#, right? While the column definitions are just like SQL. So it's a mixture, as I said. So using extractors of TSV. So these are built-in extractors that you can use. So if your files are in TSV, you can use this. For example, if you just say dot, it will show you. So it supports CSV, text, TSV, right? Since this is .NET, you can write your custom code to process your custom file extractor, right? You can build your own extractor. You can include this. Again, full .NET, full support, correct? So that's amazing. So and using this built-in extractor, it is just creating this data structure and putting this into the variable, right? And it is outputting it to another file in a file system, and this file system is your Azure Data Lake Store, right? These are all your Azure Data Lake Store. See, but I haven't mentioned anything fancy here, because even if it was HDFS, the syntax would be same, right? So I'm just and at the end I'm just outputting the data to another new file in a CSV file using a built-in outputter, right? So that's as simple as that. That's what this job does, and you can submit this job, right? You can submit this. There is an option that you can debug a job locally, so that when a user, like when a developer tests, he doesn't incur any costs. So it's basically a test bed where you can debug your job locally. But again, when you debug your job locally, it downloads all the input data that is required from your store account to your local system. So if you are processing like terabytes of data, don't do this, because the download will be very expensive and it will like take a lot of time. So I can just choose it to run in my account, in a Data Lake Analytics account, and when I say submit, this job will be submitted. But what I can also do is I can go to advanced, okay, and I can choose the parallelism. So you see, for this account, the max parallelism is set to 30. So it's saying 5 of 30, right? So this is the job name, a dynamic name, and I can actually move this slider, right, to make this job more and more parallel I want. So this is actually the number of ad allows, if you remember, right? So the more number of ad allows, the more cost you incur. So remember that. So if I increase it to 30, it will be very much parallel in nature. Read writes will be extremely parallel, but it will incur more cost. And there is sometimes we can say job priority. So that's because basically when we want to move a job, submit a job, that like if several jobs are queued and I want to prioritize one of the jobs, I can set this. So as the number increases, the priority decreases. So 1 is the highest priority, right? So that's how it is. And just submit. So you see the similar screen, right? So now it is preparing. So if you remember, the preparing means it's compiling, it's checking the metadata, it's validating the syntax, it's validating the input files and stuff like that. The job graph doesn't come when it's preparing. It will come once it's get to the queued phase. So if you remember, when you say queued, that means it's checking if the add allows are available. So currently it is compiling, so it's done, right? The total compilation time has come to 17 seconds. Okay, and the job graph has come. So currently it is queued, it's checking for the number of add allows. So the max parallelism for my account is also 30. That means if I have other jobs running at this time and it is using certain add allows, then all 30 might not be available for this job, right? So in that case, some vertices will be uh, queued, right? So again, it has started, and it says that it has determined two vertices. So based on the input file split, it says only two chunks will be enough for us to process, and it is actually running at this time. It is processing the data. As you can see, in each there are two stages with one vertex each, because there is only a couple of vertex of the entire job, and it succeeded in 1.1 minutes. And the total compute time is 2 seconds, which is really slow. I mean really fast, right? And it just read, it's a small file, so it completed very fast, but that's how easy it is to submit and author your job in USQL, right? Now to get started, what you can always do is you can go to File, New Project. You have to install an add-in for Visual Studio which says Microsoft Azure Data Lake Tools for Visual Studio. I highly recommend you install this, and then you can get a sample application, right? So there will be once you install that add-in, you will get the Azure Data Lake in your templates, right? So you choose USQL and you say OK here. So it will create a sample application for you with some sample data that will be downloaded automatically in your local account. So all these are meant for doing locally, and you will have some sample USQL scripts as well to get started, right? So I guess it has opened. Yes. So if you see, there is some data set that is automatically there, and there is some USQL. That's the guy actually that we ran just. So you can just pull in any file to see the code, right? So it's as simple as, again, declaring some variables, extracting some data, okay, and then performing some select queries, doing aggregation operations. So all the aggregates that you see that come up for these guys, right? And then another select, and then a proper output with an order by, right? So again, there are more. So it's just demonstrating the functionalities. So you see the all SQL-like statements mixed with .NET. So it's really easy. So when Microsoft started contributing back to open source, we made one thing really clear, and we wanted to do one thing is we wanted to make our existing developers, the existing developers who are on .NET, who are on Microsoft platform, we wanted them to fully leverage these tools, right? So apart from the open source stuff, we have full support for this kind of .NET programming, right? So that's a very good news for .NET developers like me, right? So that's how easy it is to get started. So I recommend all of you to get started with the Visual Studio add-in, and you can run it on your local, right? And you do not incur any cost. You don't have to have an Azure account. You do have to have an Azure account though for the subscription to connect, but still you can nullify any cost by running all these locally and getting yourself familiar with the USQL syntax, because that is the key, as the USQL will be the our primary way to author and run the jobs, right? So yes, that's basically what I wanted to cover. So thanks guys for your time. I really appreciate it on a Saturday morning. And is there any question? You can, I think the audience is muted, but if there is a question, you can type it in, or I'll post the recording. This time I hope the recording will be successful. So I'll post the recording in the group, so you can also, if there is any follow-up question, you can still go ahead and ask there in the group, or ask me directly. I don't encourage you to ask me directly because it's a nightmare to go through each and every personal message. So put it in the group. Let's discuss it in the group so that others can benefit as well. And that's what my end mission is, to make the community more and more equipped and ready for whatever the next generation data processing softwares are tooling are coming, because that's a big thing in the industry, and a lot of people will make a lot of money out of it. So everyone should be prepared, and they should know what to go and what to not go for, right? So probably we have a quick 5 minutes for any question. If there is, you can type it in, or we can drop off.